Hi, Brandon. High-speed multipixel FPGA processing. Can you elaborate to me on what the system does?
Yeah, so this is a fairly typical web inspection application where we're synchronizing a vision and a motion system together to inspect large webs of fabric or other materials. So if you click on the hardware details tab really quick, I'll show you what's going on here. So here we have a motion drive that has a built-in encoder, and then we're sending that information from the motion drive to these 4 cards, which each have a Kintex 7 FPGA on board. Okay. And so we are taking that encoder information into one FPGA, and then to synchronize all these other FPGAs together, we're sending those signals from one FPGA to the rest. And so what we're doing is then we're taking these 4 line scan cameras and controlling one camera with each FPGA. So we have 4 cameras, so we have 4 FPGAs. Okay. And so then what we're doing is now we've synchronized the motion system with the vision acquisition system so that as we change the speed of the motion system, so does the speed of the vision system as well.
Oh, I see. Okay. So that seems, fairly a lot amount of processing that's involved. So I see quite a bit of, you can change the speed here.
Yeah, so if I turn this up, you'll see the drum increases in speed. You'll see the UI increases as well.
Okay, so that is where the massively parallel image processing comes into play. Can you elaborate?
Yeah, absolutely. So if you switch to the software details tab really quick, so what's happening here is this is the one-line diagram for each camera. So we have a Bosler line scan camera, it's a color camera. So the first thing we need to do is do the Bayer conversion. But each camera is bringing in 480 megabytes of data per second. Then when we do the Bayer conversion, we get the RGB and the alpha. That multiplies the amount of data that we have to process by 4. So now at 1.9 gigabytes of data per second.
That's immense.
That's a lot. Yeah, it's a lot of data, but we're not done yet. So now we have to do the RGB to the HSL conversion to be able to do the image processing. It's a fairly standard conversion, but it's very challenging on an FPGA because you have fixed point data types as well as arctangents to calculate. So a lot of complex computation has to happen. Okay. But now we can start to really now take advantage of the parallelism of the FPGA, because now we have all the individual colors. We can parallelize and at the same time do red, green, blue, yellow, purple, and all the rest of the colors we have in our web. So we can do our color thresholds, our binary morphology, as well as then our analysis for each color all at the same time.
So you really need a highly parallelized processing environment, which the FPGA seems to be providing.
Absolutely.
Just exactly for what the application is demanding.
Right.
Okay. So if you stitch all these together, somehow something's got to be put, by some tool. Do you have a software tool that is helping the?
Yeah. So National Instruments, we're a hardware and software tools provider. So all of our software is LabVIEW. It's a graphical system design environment that can be used to target not only processors, but FPGAs. And so what that allows us to do is be able to offer domain experts, like vision designers, the ability to take advantage of FPGAs without having low-level detailed knowledge of the traditional FPGA programming tools that are out there.
Oh, okay. So the software is nicely structured, to be able to operate on Kintex FPGAs and leverage the capabilities of what the Kintex FPGA can actually provide for these parallel processing applications.
Yeah, absolutely. So our software abstracts all those complexities away. So we take on the burden of making sure that we can that our software will work with a Kintex FPGA through any number of our hardware products. And then we really let the designer focus on the fact that they're trying to develop an algorithm that's going to meet their needs and be deployed to either a CPU or an FPGA, but the programming is exactly the same experience for the user.
Okay. So I think the results seem to be saying everything that's needed. So the number of parts per second essentially requires something like Kintex to do the processing that is needed. You have the software that essentially seems to be coming along nicely, stitching everything together. and the result is, I mean, a really high-speed web application.
Yeah, absolutely. And so right now, across all 4 of these FPGAs, we're processing nearly 50 gigabytes of data per second within the FPGAs. Okay. But it's not just limited to 4. We can put as many FPGAs in this chassis that there are slots available. So up to 17 different FPGAs, all working in parallel and tightly synchronized together within the same chassis. One of our partners actually has built this exact system, and they're inspecting webs as large as 30 square meters per second, looking for down to half a millimeter of defect detection. So really, really high performance multi-parallel application.
Wonderful. Thank you, Brandon.
Yep. Thank you very much, Ganesh.